right, so A has 3, B has 7, A has 5, B has 8, C has 7, B has 4, D has 6, C has 6, C has 4. Okay, so I just wrote down all of the first place votes. $11, so this looks like it's 16. This one is 11. Who is the winner by plurality? Clark, right? You guys all getting that? Okay, if we're now checking for the irrelevant alternatives, it says that Downs drops out. But by the way, can we do this? Can we check this if Clark drops out? Can we see if Clark will still win if Clark drops out? No, right? Clark is not irrelevant to the win. Clark is the winner. So we want to see if these are irrelevant people. It would be A, B, or D. These are the irrelevant right now to the win. So we want to see if A drops out, or if B drops out, or if D drops out, will Clark still win? And this particular question is asking if D drops out, will Clark still be the winner? Because D, again, is like, I'm the worst candidate here. I'm not even going to waste any more time and money on this. So let's see if it affects Clark's win, because D is irrelevant. So we have A, B, and C only. So it looks like A is going to be and then the D, the 6 goes to B. Actually, now we have a tie. Unless I made a mistake. 17. Double checking some things. Okay, we did not define, it wasn't defined how to break a tiebreaker. So B and C now tie. Irrelevant. Is not satisfied. But in reality, we'd have to know how the ties were broken, because it's possible that C might still win if the tiebreaker method allowed C to win. But anyway, just as it is, since we don't know the tie-breaking method, it did change the outcome. And if C is now tying with B, then this fairness criteria was not satisfied. Awesome. And yeah, if you're with your family members and you watch American Idol or any of the Voice, now you can tell your family members, hey, that method is called plurality with elimination. So you'll see it on TV, even to decide what TV channel to watch. If you're with family members you don't see a lot, maybe you want to watch the Thanksgiving Day parade, however, it's going to be aired on TV, or maybe somebody else wants to watch football, or maybe somebody else. So you guys can, in a way, you have to then vote on what channel to put on the TV. So you can use one of these methods, maybe plurality. That's the easiest and quickest. But guess what? Is everyone always going to feel like it's fair? It's impossible. You could just do your best, right? So that's what we learned today, that given those four fairness criteria, there are some methods that don't satisfy them. And there is actually not one method that satisfies all of the fairness criteria. So by Arrow's impossibility theorem, it is impossible to have a voting method that is always fair. Doesn't mean it's not usually fair. It just means that if there's a chance that it cannot be fair, every once in a while it happens.